Hello students, this is video 6 that brings you thermal stress. We have in our previous classes seen that when a body or material is subjected to force or load, it undergoes deformation and consequently stress is induced within the body to resist the deformation. However, deformation can be also caused by the change in temperature. If temperature of a body is changed, the deformation will be caused. Now, some type of deformation which is due to the change in temperature, if allowed to occur, then there will be no stress within the body. Such deformation will be called free deformation because there is no resistance, no stress within the body. However, if such free deformation due to change in temperature is prevented or restricted by force, then again deformation will be induced within the body. In other words, stress is induced within the body whenever we apply force to deform the body, or in other words, even to restrict the deformation. In both the way, we are applying force. So unless there is a force, there will be no stress. Only temperature is raised, there will be expansion or contraction, deformation, but there will be no stress. So in case of thermal phenomena, there is stress when there is no deformation. Or if there is deformation, there is no stress. But in our previous classes, there was deformation, so there was stress. If there is stress, there is deformation. But in case of thermal, the opposite is true. That is, if there is expansion allowed, then there will be no stress. And if there is to be stress, there is no deformation. Or the stress will be minimized or restricted. So we'll see these things in detail with the help of a pen and paper so that the things will be clear and clearly understood. We'll see. Let a member of length is heated to raise its temperature from T1 to T2. This is the member, the length is L. Let the temperature of this member is raised from T1 to T2. Then what will happen? Its length will increase by dl. Then the length will be increased by dl, and the amount of dl is found as dl is equal to what is the quantity of deformation or amount of dl is, if it is only due to heat, then it will be L alpha T2 minus T1. This is temperature expansion, elongation due to change in temperature. dl is equal to alpha T2 minus T1. Let us know what are these things. dl, you know, it is change in length. L is the original length. T2 is the final temperature. T1 is the initial temperature, and alpha is coefficient of thermal expansion, which is different for different material. For steel it will be something, for copper it will be something else, for aluminium it is something else, like this. So depending upon the values of alpha of different material, the change in length due to change in temperature will be L alpha T2 minus T1. If change in temperature is more, change in length will be more. If alpha value is more or less, the change in length will be more or Okay, this is the deformation due to temperature change. Now, if this deformation is restricted, that is, if the same bar is held between two fixed walls, these two walls do not allow this expansion to take place. The expansion dl is not allowed by the wall. Wall do not move, so it is the temperature of the member is raised. It wants to elongate, but the walls are fixed, so they do not allow the elongation to take place. That means the wall restrict this dl, nullify the dl by force. So then what happens is, then what will stress in the member then induced. Here, if dl is allowed, there is no stress, only deformation takes place. But here, deformation is not allowed, so now there will be stress within the body. There will be stress within the body because the dl is not allowed, it has been restricted by force. So we have to find the stress here. We also know that dl is equal to stress by E into L. Now the same dl which has been occurred, it has to be restricted by this wall. That means the same dl has to be minimized or nullified by force. So the same dl will be this one. Therefore, we can equate this to sigma by E into L dl is equal to L alpha T2 minus T1. This is because this is the change in length due to temperature. The same amount has to be reduced to 0 due to opposition by walls. So these two are equal, and what happens? The stress is developed. So stress is L cancels. Stress is equal to E alpha T2 minus T1. This is called stress. Now this stress has been induced in the member only due to rise in temperature. If the body is simply kept within the two walls, there will be no stress. If you keep the member within the wall and then raise the temperature, stress starts inducing within the body, and this stress is found out like this. And this stress is called thermal stress. It is because we have not applied any load from outside externally. We have kept the members and we have only heated this. So only by raising the temperature we have been able to introduce or induced stress within the body. Such stress is called thermal stress. Right now, for further clarification, let us solve one example. Example A steel bar of length 200 mm is heated and the temperature is raised from 20 degree centigrade to 60 degree centigrade. If the coefficient of thermal expansion is 11.7 into 10 power minus 6 per degree centigrade, find out the free expansion and also the thermal stress if the expansion is completely prevented. So, given data answer. Data given is L is equal to 200 mm. Of course, here in the question, take E of steel is equal to 200 GPa. Now L is 200 mm. Alpha steel is 11.7 into 10 power minus 6 per degree centigrade. E of steel is 200 GPa and T2 is equal to 60 degree, T1 is equal to 20 degree, Now, free expansion, that means if there is no restriction, free expansion due to change in temperature will be dl will be L alpha T2 minus T1, that is 200 into 11.7 into 10 power minus 6, 60 minus 20. This is the answer. Similarly, for if this expansion is not allowed, if it is restricted completely by the help of some rigid wall or some force, then stress will be sigma will be thermal stress will be formula is E alpha T2 minus T1. Here E is 200 GPa, 11.7 into 10 power minus 6, again 60 minus 20. We can find the stress here. This is by the help of calculator we can find the stress. This deformation, this is the stress. This is the deformation when there is no stress. That means it is allowed to occur freely. And if this deformation is not allowed to completely prevented, then this much stress will be induced within the body. So when there is stress, there is no deformation. When there is deformation, there is no stress. This is what thermal stress is all about. Okay.